What is up, ladies and gentlemen, boys and girls, programmers of all ages? Welcome back to the third take of this week's HaxeFlixel game development tutorial. It's not been a good week for your boy. Your boy's been struggling mentally. Let's just leave it at that. Anyways, this week's tutorial we are implementing the heads-up display, or the HUD, to start, and also the level 2 of our game, so that we can keep the ball rolling, make things go a bit faster, so that we don't have like 3-4 episodes of the same thing over and over and over again. So since you've seen level 1, it's pretty much the same, just with different monsters and different map layout, but I will walk you through it step by step. To get things started, let's open up a new folder called hud.hx. It's going to be a class HUD extends FLX typed group. I was about to ask where my autocomplete is. So it is a group of sprites. Let me also import sprite if I can. Yeah, import. Awesome. Just move those curly braces down. Now you will notice that we do a lot of similar things between setting up this HUD and setting up a normal menu. The only difference is that we'll have the game running in the background, where in menus you don't really want that to happen. It would be a bit of a mess. In any case, let me just quickly import these things. Import. So we have a private variable for monster counter that is of type FLX text, and then we have 4 buttons for the 4 types of projectiles that the player can access. These buttons will be used to click on to change the projectile type which the player fires. It's as simple as that. The monster counter is of type text and the buttons are of type FLX button. Now for the constructor, we'll say, we can just probably say new, and then it takes a reference to the player, since we want to be able to change the player's projectile type. No, no, turn off reminders please. Okay, we want to call the parent constructor, which, if you know object-oriented programming, is the FLX type group. If you don't worry. It's really weird how object-oriented programming works, and a bit out of the scope of this tutorial series. But you can always just check out like Java programming tutorials to get an idea of how it works. So monster counter equals new FLX text. Don't get used to me typing this out. I'm going to switch back to copy paste just now. Monsters left equals 0, and then we have a text size of 10, and then we want to add monster counter to our group. Cool. Now for our first button, it is the eyes button. Let me just import FLXG. No, wait, that's the wrong one. Import. Okay, so ice button equals new FLX button at 0.00 with the text of ice bolt. If the button is pressed, we want this lambda function to be called, so that the player.set projectile type to ice bolt gets ran, and that way it will change the projectile type of the player. We want to center the button on the x-axis, so it's in the middle of the screen. We want to position the button at the lower end of our screen, so that it's at the bottom and away from where the player is usually looking. We would then want to move it a bit to the left, so that since we have 4 buttons, we'll have middle space be empty, and then we add the button to our group. Next up is the poison button, very similar to the ice button. It's a new FLX button at 0.00 with a text of poison bolt, and when the lambda function gets ran, it changes the projectile type for the player to poison bolt. We center it on the x-axis and then just a bit above the bottom of the screen, and then we move it a bit to the right to make so that there's empty space in the middle between the poison button and the ice button. Next up, let me just scroll down a bit. We have the fire button, which is a new HaxeFlixel button at 0.00 with firebolt as the text, with a lambda function that sets the projectile type for the player to firebolt. It's a bit above the bottom of the screen and to the left of the ice button. And then the last button is the shock button, which is a new HaxeFlixel button at 0.00. We give it the text of shock bolt and then a lambda function that sets the projectile type for the player to shock bolt. We put it a little above the bottom of the screen and to the right of poison button, and then we add it to the group. Now, you might have noticed, if you have tested it out with UI in the game thus far, if you've maybe gone off on your own a bit, you will notice that if you try to add UI to the screen and set it at 0.00, for instance, the moment that the player starts moving, it doesn't stay at 0.00 on our screen. It's on 0.00 in game space, not screen space. So what we need to do is to change that so that each of these buttons is in screen space rather than game space. So we say sprite sprite dot scroll factor dot set 00. So what this will do is it will loop through each sprite currently in our little typed group, and then set the sprite scroll factor to 00. That way, when the player moves, the buttons and the text won't move with the player. They will stay statically in their screen space position. You could have done something similar for the health bars if you wanted to, but I prefer a health bar that moves along with the player and the boss monster rather than just staying stuck somewhere on the screen. Next up, we have an update function, which is public, which takes the amount of monsters currently left in the level, and then it sets the text to monsters left and then inserts amount of monsters into the string. And that's about it for our heads up display. Pretty easy, right? Pretty slick. I like it. Next up, let's quickly update our level 1 before we go, so that level 1 gets the same amount of love that the level 2 will get. So first, we have a private variable called _HUD that is of type HUD. And then way at the bottom of our create function, let me just go check my notes so I don't lie to you guys. HUD equals new HUD, and it takes a reference to the player. HUD.update HUD. It requires the amount of monsters currently in our world, and then we add HUD to our scene. The amount of monsters we give it will be the initial amount that we got from loading the entities. As you will remember, if we scroll down a bit to the load entities, every time a monster gets loaded, the amount of monsters is incremented by 1. So this will ensure that when we start our level, that the amount of monsters is already representative of how many we have in game. Now over to the overlap function between melee monsters and projectile monsters. We want to say _player dot health plus equals 20. That way we can, every time a monster gets killed, we increment the health of the player by 20, since the idea is that the magic of the player runs off of living energy, which is in all creatures moving in the game and even the non-moving turrets, since the evil eye monster used living souls to create the turrets in our air quotes game lore. So if a monster gets killed, we want to say HUD.update HUD with the amount of monsters. Now we could have just set this in the update function itself every time the update function gets ran, which is like if it's 60 frames per second, 60 times per second. But it's a bit wasteful, I think, and really unnecessary. So whenever a monster gets killed, then we update it. Otherwise, just leave it. It should stay the same. There's no reason to update it every time. And that's about it for the level 1 state. Now let's move on to level 2 state. Now I am gonna do a lot of copy paste to get things going a bit quicker, since it's really similar to level 1 state and to all the other test states that we've done, minus now we don't have HUDs in the test state because there's infinite amount of monsters. In any case, let me just quickly import. Let me save after that import. Import, and I can delete that line. Cool. Now we have a player variable, a ranged monsters typed group, projectiles typed group, a map variable, a walls variable, amount of monsters variable, a health bar variable, a background music array of strings, a sound effects array of HaxeFlixel sound, and a HUD of type HUD, which is pretty similar to level 1 state. You should have noticed. Now we want to override the create function. Okay, let me just quickly import these things before I start with the explanations. Can you please work with me? No, wait. I'm doing all the dumb stuff. Okay, that should be it, minus now color, which also needs to be imported. Cool. So we start off by setting the world bounds to a 2000 by 2000 square. That way the collision detection will work out everywhere on our map, not just on some points like you may have noticed earlier in our tutorial series. Then we load the map using the introduction to HaxeFlixel OGMA file and the level 2 map JSON file. We load the tile map. We set the camera to never go outside the bounds of the tile map. We set collision on the first tile and do not set collision on the second tile, and then we add the walls to our scene. We add the projectiles to our scene. We add the player to our scene. We set the camera to follow the player. We add the ranged monsters to our scene. We set the amount of monsters to 0 and then run the function to load all the entities of our entities layer into the world, where we will then, sorry, it's like ghost sounds coming from the window, just like checking things out. In any case, we'll then add the health bar, create a filled bar, set it to track the parent 20 pixels above and to the right of the player, and then add that to our scene. Next, we create an array with all the assets of our music folders. Then we start playing a random song from that array with a volume of 1 and a looping of false. We say that if the music stops playing, that we want to set the music to null. That way we can check in our update function to restart the next song. We then load all our sound effects files into the game and give them little comments so that we can more easily reference them in our game later on. Then we load the HUD, set the amount of monsters on our HUD, and then add it to the scene. And that's it for our create function. Now onto our update function. Okay, so if the music is null, start a new random song. If the player's health is less than 100, start healing the player. If the player's health is more than 100, take it back down to 100. If the player's health is less or equal to 0, start the death menu by fading to red and then switching states over to death menu state with a new level 2 state so that we can restart this level. If the amount of monsters is less or equal to 0, then fade to green and then switch states to a when menu state with level 3 state as a variable so that we can know to start that if the player says next level, we go over to level 3. We set the health bar dot value equals to player dot health. We handle input. Okay, so collision detection, if for each for each projectile that is still currently alive, check the age of the projectile. If it's greater or equal than 2, then we want to kill off the projectile. This is just a bit of memory management so that we don't have infinite projectiles currently loaded in our game. Next up, for each monster alive, check to see if that monster shoot fire, and if we shoot a ray from that monster to the player, if that ray is unobstructed, so in game, if the projectile can air quotes see, if the tower can air quotes see the player, then it will return true. So if it shoot fire and it can see the player, then create a new projectile, add it to the projectiles, and play the corresponding sound. Next up, collision detection between the turret and the projectiles. If the projectile was shot by the player, then kill the monster, kill the projectile, decrement the amount of monsters by 1, increment the player's health by 20, update the HUD, and then play a death sound for that turret or tower, however you want to refer to our ranged monsters. Next up, check if the player gets shot by a projectile. If that projectile was not spawned by the player, then kill the projectile, decrement the player's health by 10, and then play the sound effect for the player getting hit. We make sure that if a projectile hits the wall, then we should just kill the projectile so it doesn't like bounce off or like go through the wall or something. And we check collisions between the player and the wall so that the player can't go through walls like he is Danny Phantom. Okay, that's it for our update function. Next up, our entity loading function. So for each, let me just import these. Okay, so for each entity currently in our entities layer, if the entity is a player, then teleport the player to the X and Y coordinates of where he should be on the map, or she should be, or it should be, or they, or whatever pronouns you want me to use. If it's a ranged monster, then spawn a random ranged monster at that position and increment the amount of monsters by 1. If it's neither a player nor a ranged monster, then we're trying to load a map which we really shouldn't be loading, so throw an unrecognized actor type and then the name of the actor we're trying to spawn. So this will crash the game, but it will give us an indication of we are doing something we shouldn't be doing in any case, so the game shouldn't be running at all. And then last but not least, handling input. If the left mouse button is pressed, get the position where it is pressed, spawn a projectile that moves towards that position, play the fire animation for the player, decrement the player's health by 1, and then play a firing sound depending on the projectile type of the player currently. If the escape button is pressed, then open the pause menu. It's as easy as that. Okay, now let's see if we can test out a game, but before that, I just want to quickly check something. Okay, it doesn't look like my recording software is currently trying to commit uninstall live. I have my laptop set on silent mode, which means it's a bit less powerful than usual, but you shouldn't hear the fans in the background spinning away, I hope. But let's test the game. So if we open a terminal using Control tilde, or tilde, I don't know how to pronounce it. It's this little symbol, or technically this one, but it's the one below your escape left from 1 usually. If you're using a QWERTY keyboard, it might be somewhere else on yours. In any case, we type line test hl-debug and then run it. We'll be back as soon as this has compiled. Okay, it's just about done compiling and our game is loading in. Cool, it has loaded. Let's play level 1. Okay, so we have the HUD. We still have all our firing capabilities that we used to, and you'll notice that my health bar stays pretty full, and that is because I am slaying these monsters, and which results in me constantly getting more health than I am spending, and I'm dead. Okay, exit to main menu. Let's try level 2. Level 2. So the fire animation starts up but doesn't actually fire. Now if we move down, and then it fires, and we can still shoot them. And because we get pretty much healed instantly, we can just tank the shit out of this game. Unless all of them at the bottom fires at the same time, then you are pretty screwed. But better strategies are to be had than just simply running and gunning. In any case, if you enjoyed this week's HaxeFlixel game development tutorial, feel free to drop a like, subscribe, tell a buddy, tell a friend, tell a family member. Let me get up to those sweet monetization levels of followers. In any case, I hope you have an awesome week. Until next time, goodbye.